Okay, so section 1.3 is evaluating limits analytically. Basically, that just means you're going to be using your algebra to figure it out. Now, one of the two main things that you need to start with is just the fact that when you have the limit of x going to c of some number, so I'm just going to put b, and b is going to be a constant, so it would look like the limit as x goes to 2 of 3. So whenever you have a constant like that, then all your answer is going to be is just that constant, because basically there's no way that you have any x in there to put your 2 in. So this answer is just going to be 3. So you're trying to take the limit of a constant, it's just that constant. The next one is the limit as x goes to c of x. And that, you just plug in. You're going to get c. So you might see something like the limit as x goes to 5 of x, and that answer would just be 5. You just plug it in. With those two ideas, you can basically do everything else with your algebra. Alright, before we look at those though, let's go ahead and look at our basic properties of limits. Alright, so the first one is, let's say you have the limit as x goes to c of b of f of x. So basically you have a scalar multiplied number out in front. That looks kind of funny. And I'll write it again with numbers so you'll know what I'm talking about. Okay, so in a problem like this might look something like, what if I'm doing the limit as x goes to 2 of 3 times x? From the previous example, you know what to do if it's a plain x, but since you have a 3 out front, then that doesn't give you the same example. So what we can do here then is know that this formula says go ahead and take the b out front and then do the limit as x goes to c as your function. Alright, so in this case then it's just going to be 3 times the limit as x goes to 2 of x. And by the second property that I showed you, that would be, just go ahead and plug that number in, so we get 3 times 2, so 6. So anytime there's a coefficient out front, you can pull it out or just factor it out into the front and then just evaluate your limit like that. Okay, next one. If we have the limit as x goes to c, some number, could be a number or it could be infinity, and let's say we have f of x plus g of x. Right? That's going to be equal to as if I just distribute the limit. So we can distribute limits inside the summation of two functions. Alright, an example like that would be, let's say I got limit as x goes to 3, and my problem will be like x squared plus 3x. See, I don't have a rule for polynomials, but according to this, I can distribute my limits inside. So this will become this. Alright, now here, this is a power. I can go ahead and take it inside the power because that's another rule that's coming up. So that would just basically be 3 squared. And right here, I can pull the coefficient out front like I did on the last example. And if I pull it out front, then my rules tell me that I can do the limit and just put the 3 in there. So that's going to be 3 times 3. So I'm going to get 9 plus 9, which is 18. Alright, and that doesn't matter if you have a plus. You could also do it if you had a minus as well. You can distribute across both. Alright. Now, let's see. Product. Let's say you got the same kind of scenario. And you want to take your limit as x goes to c. But this time, your functions are multiplying. Alright, in that scenario, you can go ahead and just take the limit of both of those, like you're distributing it as well. That doesn't normally happen in algebra because we don't ever distribute across multiplication. But here with limits, we can. Okay, so let's say I'm going to do the limit as x goes to 2, and I'll have, I don't know how I can make them, I'll just say I got x squared times x. Obviously that's x cubed, but in the scenario what we're going to do is we're going to take the limit to both of them, and I'm not going to rewrite it all like I did the last problem. I'm going to take the limit of that times by the limit of that, because I'm going to kind of do this in my head. It's kind of simple. So I'll plug my 2 into my x, and that will be 2 squared. And then I plug my 2 into there and get a 2, so 8. Alright, and then, oh, let's see. I'm going to have to erase some of this. Alright, so next, what do you do if you have a quotient? What do you do if you're dividing? Well, same scenario there. You're going to distribute it in. You're going to put it in the top and you're going to put it in the bottom. So if I have a limit as x goes to c of f of x divided by g of x, you're just going to plug it in. Well, sorry, that's what we're going to basically do, but it distributes to the top and it distributes to the bottom. Alright, an example. What if we have the limit as x goes to 2 of x squared over x plus 1. So I can go ahead and separate that, put the limit on top. And on the bottom. Plug it in. We get 2 squared over 2 plus 1, which is 4/3. So basically, really all we're doing is just plugging it in. Alright, and the last one, you can do that with powers as well. Oops. So let's say I have a function, f of x, but you notice there's a power. And that we've kind of already done already with my examples. You're just going to go ahead and plug it in. And that would be like that in the rule. Your example for that, well, we've already done it right here. This is a good example right here. We just take it and we're going to plug it in. Alright, and last, let me just add this real quick. If you happen to be doing the limit of a square root or a cube root or any root, what I want you to do is take that root and just imagine it being a power. And then you're going to treat it just like this ruler right here. Bring it in, find your limit, and then do the radical of it. You can either use it as a power or as a square root. Alright, now basically then, let's look this overview. What this means is really all you're going to do is plug it into your function. And only when we have a problem do I worry about anything else. Alright, so the last examples I gave you totally have you plugging them in basically, doing it the long way. But shortcut, all you have to do is plug in. So if I have the limit as x goes to 0, let's say I have x squared plus x plus 3. The correct way to do it would be knowing that you could distribute that limit into all three of those terms. Then on this one you'd use the power and bring the power down in front, and then you would evaluate. But basically it's the same thing as if you just plug it in. So that's going to be 0 squared plus 0 plus 3. So my answer is 3. Alright, now, that's all fine and dandy until you run into something where you have a problem. Like let's say you have the limit as x goes to 1 all over x minus 1, and on top we can have x squared minus 1. So if I were to plug this in, I would end up with 0 over 0. And since I have a 0 in the bottom, anytime you have a 0 in the bottom, not good. So in this problem, we're having a situation. So what we're going to do here, our first thing we're going to think about doing is factoring top and bottom, and then canceling out what's common and trying it again. So this will be the limit as x goes to 1. The bottom is factored. The top can be factored to x plus 1, x minus 1. Now these factors will cancel out, leaving just the x plus 1. And you try it again, and if it works, you're done. So 2. Alright, now what to do after that? Well, let's say you do that and you're still having a problem, like you're still having a 0 in the bottom. Well, another thing you can do is you can try rationalizing. Rationalizing is when you multiply the top or the bottom by a square root or by a conjugate. So let's say I have, let's see if I can find an example so I don't give you crazy numbers. Oh, I don't even want to look at this problem, but let's do it. The limit as x goes to 0 of square root of x plus 1 minus 1 all over x. So in this scenario, I can't put the 0 in the bottom, so I'm having a problem. And if I think about factoring, I don't really know how to factor that. So one thing you can try to do is rationalize. So I'm going to multiply the top and the bottom by my top number right there. That's the one that I can rationalize with. So I'm going to do x plus 1. Now, when you're rationalizing, what I want you to do is I want you to use the conjugate of what you see, and that's when I'm going to change that sign to a plus instead of having a minus. Do it to the top and bottom. Alright, on the top you can see that when I multiply my first terms, I'm going to get just x plus 1. Now this is the difference of squares, so your inners and your outers, when you multiply those and you multiply those, they will cancel each other out. So all I have to worry about then is my last term, which is a minus 1 squared, or minus 1. Now on the bottom, then I've got x, square root of x plus 1, plus 1. Alright, now, oops, I forgot my limit. Limit. Cleaning that up. I'm going to get x on top, and on the bottom, can't do much with that, so I'll just leave it the way it is. Alright, I'm going to plug it in again, and I'm going to try it again. So I got 0 on top, 0 times the square root of 0 plus 1 plus 1. Well, that's not good. Still have a problem. Oh, wait, silly me. Silly me, silly me, silly. Let's back this up. Alright, so the first thing I'm going to do is cancel out what's common. So I can cancel out both those x's. So I've got the limit as x goes to 0 of 1 over square root of x plus 1 plus 1, which would be 1 over square root of 1 plus 1, so 1/2. Now it works. Alright, so step 1, plug in. If that doesn't work, step 2, try to factor. If that doesn't work, try to rationalize. If those 3 things fail, you have to do a chart like we did on section 1.2, where you actually plug in values really close to whatever you're looking at. Alright, one last thing I want you to do and memorize this is, and if you don't memorize it, you'd be like, oh my gosh, it just bit me in the butt for no reason because that was so easy. Alright, so we've got this rule you have to memorize. Alright, every time you see that situation, or something similar, maybe you have 4's on top, like 4 sine x over 4x, you can factor the 4 out. But every time you have that situation, you know the answer is going to be 1. And this one will be 0. And I can show you using the squeeze theorem, which is a really cool theorem, and I'll probably show you in class because it's just cool, why that works. But basically, just memorize those two little factors there. Most and oftentimes, more than not, you'll have the sine one and not the cosine one. So this one is like really cool. It makes your mathematicians happy, and you'll probably see it on your AP exam. So keep in mind that you should have that memorized. Okay, yeah. Remind me tomorrow to show you the squeeze theorem. Woo! Lots of fun. Good luck on your homework and your notes and trying your homework, and then I'll see you tomorrow in class.